is actually a professor of computer science and a senior machine learning engineer, Walid Ahmed. And we're very thrilled and excited about this session. Usually when we start this program, we'll talk briefly about AfricaHacks and STEMHub Foundation. Uchi, do you want to get started today?
Yeah, for sure.
I'm going to stop sharing my screen.
No, I don't have a slide today. I'll just talk.
All right, okay. He is actually a professor of computer science and a senior machine learning engineer.
Okay, yeah. So my name is Uchi and I'm the founder of AfricaHacks. I'm really happy to have everyone here. Thanks, Dr. Adi. So AfricaHacks, we're on a mission to provide opportunities for African and Black youths to build companies. And currently our focus is on providing a platform that they can use to find team members and then validate their ideas. So on this platform, you can find like-minded individuals. And then if you have an idea that you're looking to work on, you can easily find team members here, post your idea, and then discuss it with these team members. And then from there, you get all of the resources that you need to build a company. So that could be access to cloud services or other services and training that you require. So if you want to try this out, check out start.africahacks.com. You'll be able to do all of these things that I've said. That will be all for AfricaHacks. I want to pass it on now to Dr. Adiola.
Thank you very much, Uchi. And one thing that I always say as an engineer is that collaboration is a big deal. Without collaboration, we will not have a lot of the innovations that we use today. So AfricaHacks provide everyone an opportunity to not only work alone, but to be able to, get your idea to a point where it will be fully formed in a team-based environment. So if you are buzzing with ideas, you have multiple ideas, you're thinking about different things, AfricaHacks is that place that can help you consolidate your idea, streamline it to what works, and really help you get started with it in form of a created company. My name is Dr. Adiola Olubamiji, and I am the founder of STEMHub Foundation. I'll not go through all of these slides because some of you have seen it, so I have a few slides to share. STEMHub Foundation is a Canadian non-for-profit that was started in 2017. And we're actually actively working to increase participation of visible minorities, females, and underserved youth in STEM. And some of the programs, our vision is to make sure that individuals can thrive without those barriers that hinder females or minorities, and not only thrive in their STEM careers, but also be able to get into those leadership roles. And we have created 5 programs that we're using to really challenge the norm in the society and to really help bring STEM to our community. One of them is STEMming. It's our hands-on activities where young people at different community centers learn about different STEM concepts in a friendly manner from professionals who actually work full-time job in those fields. We also have a one-to-one mentorship program where we connect professionals and students who are in school or just people who are just graduating from university. The idea for this came about because we realized there's a disconnect between what the university is teaching and these days, the skills that are required for you to be competitive when you're looking for a job, especially because of Industry 4.0. So we connect professionals to students who are still in schools to help them be able to take the right courses, obtain the right skill sets, and also have access to professionals when they're looking for a job. That's a very good opportunity for networking. Third, one of our programs is Mentor Meets the Community. Every month, we send one of our professionals to different community centers. The idea is to be able to explain what is a day like in your life at work. If you're a mechanical engineer, aerospace engineer, computer science, data scientist, what do you do? And what is a day like in your life? These young people are also able to ask questions from these professionals to be able to kind of have an idea if they want to go into this career path, what is the options that they have. We also have a program called STEM Scholars where we disseminate scholarship information to people online. And also under this program, we've launched an initiative where we are challenging companies in Canada to actually send people back to school on scholarship. The idea is because COVID-19 is ravaging the world and a lot of parents are losing jobs. Youth who could work during the summer to save money for school couldn't do that this summer. So a lot of students are undergoing pressure in terms of financial needs. So we're reaching out to companies to be able to offer scholarships under our STEM scholars to students going back to school. And we're excited about some of the scholarships that we'll be advertising next week to youth going back to school in Canada. Our last program is called STEM Exposure, where we want to expose young people and their parents to different industries for them to have an idea of what type of work environment will you work if you choose this career path. We want to educate not just the youth, but also the parents, because sometimes when you're choosing careers, if your goal and your parents' goal don't align, that could be a problem. We're excited to be offering this Tech Masterclass. Thanks to COVID, everyone is home. This is our new initiative, and we're thankful to you that you have chosen to spend another Saturday with us. That is everything from STEMHub Foundation, and now I will move on to introducing our guests for today. Hold on a second. So our guest for today is Professor Walid Ahmed. He's a professional engineer. If you're Canadian, you know what that means. Professional engineers are people who are certified by a governing engineering bodies to be able to do engineering work within Canada. He has a PhD in electrical engineering, and he has worked as a full-time professor, mainly teaching programming courses such as Java, Python, and web programming. Dr. Ahmed currently works in the industry as a senior machine learning engineer and is an expert in machine learning, deep learning, and computer vision. He has 2 patents and more than 40 published research papers in the field of intelligent systems. Dr. Walid, we're very happy to have you on. You may please get started whenever you're ready.
Yes, hi everyone. I'm very happy to be here. It's a privilege for me. I hope you will enjoy my slides. And when I start my first slide, will have my email, so feel free to contact me anytime. You can find me also on LinkedIn. So let me start by sharing my screen. Okay. So let me first start by introducing myself and how machine learning helped me in my career path. So before moving to Canada, I was a professor. I was teaching, but at that time I was fond of machine learning and AI and soft computing. Since I moved to Canada from more than 4 years, I found that more opportunities are found in industry than academia. And this is where machine learning helped me to find a job. And then I became like a professional engineer, and then now I'm a senior machine learning engineer. So learning machine learning was very helpful to me. It helps me a lot. It's a very interesting topic, and I think it will stay interesting maybe for decades now. Every day there is something new. So if you have a passion for machine learning, you will be happy every day to get updated with the tech news and everything. So the job market for machine learning, it's a very high demand now. Although with COVID-19 things going around, it's the job market is slowing down a little bit. But I think after COVID-19, things will return back. So it is in demand in Canada, it's in demand in USA, it's in demand in Europe, and it will stay in demand because the applications now for machine learning and for deep learning, we just don't know what to do, what it can do yet. So more ideas are coming, more startups will open. Google, Amazon, Facebook are spending a lot of money investing in these areas. They are buying a lot of startups also. So it's something booming, and it's definitely a very good thing if someone would like to work in IT machine learning or change his profession into something IT to go directly to machine learning. So let me start first with some definitions from academia about what is machine learning. So machine learning is a field of study that gives computers the ability to learn without being explicitly programmed. So what does this mean exactly? It's like if you have a baby, you are not teaching the baby everything. If you have a child, you are not teaching him on a daily basis everything that he would encounter, but you give him the ability to learn. And with the ability to learn, he can follow up and he can learn and deal with new things and new stuff. So this is the same thing that machine learning is trying to do. It gives the computer the ability to learn without telling exactly every instance, everything the computer will see. A more standard and new definition for machine learning is a computer program is said to learn from experience E with respect to some task T and some performance measure P if its performance on T as measured by P improves the experience to E. Although this looks very strange, but this is a very good definition. So there is some experience. There is experience that you will introduce in your code. This is experience E. Your code will be able to learn from experience, and your code is trying to do a certain task, T. And your computer can measure whether it can do the task in a good way or in a bad way using the performance measure P. So we have E, the experience, T, the task, and the performance measure. If you found that the performance on T as measured by P improved with experience E, then we are having machine learning. So when you give more experience, when you give more data, and you see that your performance is getting better on your task T, this means that your machine is learning. So if we take an example, a very useful example for the spam email, this is mainly this is like a typical application for machine learning. People build machine learning engineers build a model. You'll hear this word model a lot. This model is able to differentiate between spam emails and not spam emails, safe emails. So it will get an email and it will classify it either to spam or not spam. So the task here is to classify the emails, detect spam from not spam. This is the task T. The performance is how many good emails are actually classified as good and how many spam emails are actually classified as spam. This is the accuracy. So what about the experience? What is the experience here? I have a lot of emails, of good emails, and I have a lot of spam emails. And using this large repo of these emails, this is the experience. I will just kind of throw it to the computer and ask the computer to learn and find the rule, so that now when a new email comes, our model will be able to distinguish whether this is a spam email or not spam email. And for sure, if you increase the experience, if you increase the number of emails, which we call training data set, your machine learning will be better. And actually, on a daily basis, now we see that this junk email thing, this is spam email, is getting actually better and better. Now, before that, you used to have some spam emails in your inbox, but now I think the spam filters are much better. When you actually open your spam folder and click on an email and say that this is not a spam, you are actually giving more experience to the model and to the email provider, like Gmail or Outlook. It will know that, okay, I made some decision wrong. This is not a spam email. So based on this experience, it can actually improve. Okay, so you'll hear the word model a lot. So for a machine learning model, you have an input and you have an output. So when you design a machine learning system, you always have this model. It will run on the computer. This model can come from a neural network, from a support vector machine, from different machine learning disciplines. But all the models will have some input and some output. In our case, the input was the email, and the output will be like a classification of these emails, whether it is a spam email or a good email, a safe one. Okay, so some buzz keywords and some main keywords if you are going to deal with machine learning is the word classification and the word regression. So what is classification and what is regression? So classification, it's about predicting a label, just a label, like a category. Like saying that tomorrow will be cold, tomorrow will be hot, tomorrow will be rainy. So you give like a label. This is a type of classification. But regression is about predicting a quantity, like telling exactly how will be the temperature. Tomorrow the temperature will be 84. Tomorrow the temperature will be 27. So there are two like distinguished directions if you are going to do machine learning, whether you are after classification or you are after regression. So classification deals with categories where you would like to classify a certain category. Regression, you are outputting like a number. If you are dealing with a stock market problem, you can classify you can deal with the problem as buy or not buy, then it will be a classification. If you have if you model your problem as a regression problem, you are trying to predict the price of the stock price next day or something. So you output the quantity as the price of the stock. So some of the simple standard ML problems will be like predicting house prices. This is a regression problem because I need to predict the price of a house based on some information about maybe similar houses. I should have like still a training data set. Predicting an email if it's spam or not. This is a classification problem. Predicting if a tweet about a movie is a positive or a negative review. This is something very common. Also, people to get used to the machine learning is download the tweets from Twitter, and they can like learn how to say, okay, this is a positive review or this is a negative review. It gets even more difficult if there is some sarcasm in the review, so you couldn't be able to distinguish whether it's positive or negative, but your model should also deal with these sarcasm. Okay, so also looking on machine learning, you will find that there are like 4 other. So from regression and classification are from maybe the application point of view. But machine learning can be broadly defined into 4 typical ways of learning: supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. The typical one that people are using mainly now is the supervised learning. It's a straightforward one. Semi-supervised and supervised are not that they are still applied, but they are not that popular as supervised learning. Reinforcement learning is kind of booming now, and a lot of people are using it. So we'll have just a quick view on these 4 techniques of learning. So for supervised learning, supervised learning can be used for classification. It can be used for regression. For supervised learning, you have a training data, but this training data is labeled. So if you have like this training set of the emails, some of these emails, all of the emails that you are using for training will have a label. Like this one is okay. This is a good email. This is a spam email. So all your data set is labeled, and you will use this data set in your learning to build a model that can distinguish if a new email comes, whether this new email is a good email or a spam email. Same like if you are doing regression. So I have a value based on a certain feature. So I have these previous values based on this feature, and then like I'm having like a new feature, and I would like to know what will be the value. So all these values, I have the values related to the feature. Now I have a feature that that I don't know about. I have the value of this. I have this new instance of feature 1, and my model can predict the value. Supervised learning is the standard one people are using, but it comes with a drawback, a huge drawback, that you need someone to label your data set. And this actually opened like a side market for labeling of data. So in like not in my current job, in my previous job, we had like people hired to do the labeling, like persons. We call this person in a loop because you need some human to do the labeling. And actually, they do it even for images. Let's say that you have a huge data set of cats and dogs, and you would like to build a model that can classify whether this is a cat or a dog. So you will hire some people to do the classification for you to build a training data set if you cannot find something online or another data set. But usually things are complicated because some cats will look like dogs, some dogs will look like cats for a human being. And you would actually you end up hiring like 5 persons to do the labeling, and you take like the average of classification of them. This is all to do training, build a training data set. There are companies here in Canada, in USA, even in, I think we had a company helping us from Mexico. Amazon actually is offering this platform for doing the label for the data set. But anyway, you will end up having this label data set, and you will use it to train your model. Unsupervised learning is much easier. Your training data is unlabeled. You don't care about labeling the data, but still your system will try to learn. It will try to learn something. So a typical example for unsupervised learning tasks will be clustering and anomaly detection. So what do you mean by clustering? Let's say that we have these points, originally unclustered data, and you would like your machine learning to group them together, to find the number of groups. If I'd like to, okay, I have all these points, I would like to group them into like 3 groups. So your machine learning algorithm will be able to classify, not to classify this time, but I mean to group, to cluster that these points are related, these points are related, and these points are related. Here we choose like 3 clusters. What about 4 clusters, 5 clusters? So there are a lot of research doing how to get the number of clusters. But when will this be helpful? It's mainly used for marketing. Let's say that you have a lot of customers in your company and you'd like to group them. You don't know the best way to group them, whether it be age, whether it be zip code, salary, job, whatever, you don't know. So you let the computer build a cluster and maybe find like a marketing strategy for each cluster. Even for, so maybe it's used for marketing. It has other also applications in industry, like a factory is producing some t-shirts with different sizes and would like to have them like small, medium, and large. So they do the clustering also so that they will know that this will be the small, this will be the medium, this will be the large. In some documents also, let's say I have a lot of documents coming, I don't know the labels. For them, it's unlabeled, but I would like to like group the documents maybe into 5 or 6 categories. I don't know the name of the categories, but I will leave it to the computer to distinguish between these different clusters. So it's something like this also. If you feed the computer with this input, like different sports ball, and the computer can see a certain pattern and it will distinguish them. The computer doesn't know that this is a soccer ball. This is.
I wanted to interject, if it's okay.
Yeah.
Hi, everyone. Today, we're going to have opportunities to answer some of your questions on machine learning and computer vision. If you look on your dashboard, you will see a question and answer area. Professor Walid has volunteered to help you answer a lot of questions that you might have regarding this field. Please drop your questions in the question and answer box. So the plan is after an hour, we'll take a break, we'll pick some questions, it will help answer them, and then we'll continue. Please drop your questions so we will have questions to review when we are ready, when we get to the 1 hour mark. Thank you, you can continue.
Okay, thank you. So we were talking about clustering. So the computer now we will feed, in this example, you will feed a lot of images for balls, for soccer balls, and it will be able to distinguish and group them together without giving them a label. But okay, there is some hidden grouping information that the computer can learn, and it will give you the cluster. This is clustering. The other application for unsupervised learning is anomaly detection. So anomaly detection here is like you feed a lot of values to the computer, like this one, like for feature 1 and feature 2. So you have a lot of points. And when a new instance comes, the computer can say whether this is a normal instance. This is something that we can say that it's usual to have it, or it's an anomaly. It's something that it's not normal to have. So we don't actually, you're through to the computer like 1,000 points. Some of them will be anomaly, but you will not have to label these anomaly points. The computer will be able to learn what is normal and what is anomaly. And this simple technique is used in like fraud detection for visa transaction, that the computer will flag that this is an anomaly behavior. Maybe someone is always buying things from Canada, now he's buying from another country. He's spending a lot of money. He's buying things that he didn't use to buy before. So the computer will raise the flag that this is an anomaly. Okay, the other one is semi-supervised learning. It's something between supervised and semi-supervised, where you have a lot of unlabeled data and a little bit of labeled data. And this is semi-supervised learning, and you use them to train a model. A very typical example would be Google Photos. You take a lot of photos for people. Google will detect the faces in the photos, and we start to do some clustering for the faces to see that, okay, these faces are similar, these faces are similar, and then it will ask you, is this is this someone? Give me a name, and you start labeling yourself. So you are doing this little bit of label data, and after that, the computer will use this information to build a better model. So it's usually like a mix between unsupervised and supervised learning. The other type of learning, which is kind of different from the other three ones, is reinforcement learning. So in reinforcement learning, it has like a different set of words. It has something like an agent, and this agent is doing an action in the environment, and based on his actions, there will be like an interpreter which will measure how did he affect the environment, and will return a reward or actually a penalty to the agent, and it will also return the state of the environment based on the action taken by the agent. So the agent will learn based on whether he is getting a reward, whether he is getting a penalty, and will update something called the policy. So now that the next time he will take an action, it will be a better action. So this actually is used in robotics. If you would like to a robot to find his path or something, and even if you are like training your dog, you start with no information at all. So he take an action. You either give him a reward or a penalty, and he will observe that he took and he will observe all the change in the environment that happened based on his actions, and the dog will learn to update his policy. So he starts with nothing. He starts without any information. But here the agent can take some actions, and based on his actions and based on the penalties or rewards he will be taking, he will be able to update the policy. Okay, so what can we do with with machine learning? One of the very nice fields of machine learning is computer vision. Although now it raised a lot of concerns about privacy, but we are enabling the computer to understand images, to understand videos. It's worth mentioning also that all what we are doing is we are trying to make the computer intelligent. So you might spend like a day building a classifier whether this is a cat or a dog, but a kid like 5 years old can distinguish a cat from a dog. So it's a lot of learning path that a lot of applications. So it's not only to build an application like human can do, you are trying actually to build an application that will be better than a human. And there are some cases now that a computer, a machine learning classifier can do better than a human. It actually can. So even sometimes in my work, the computer can classify something that a human missed to see. Like so, let's take like 2 examples to see how can computer vision help. So this is fast mask detection. So the computer here will detect if there is no mask or there is a mask. How can a computer do this? It's actually also, it's just machine learning. So what you do is that you feed this video to the computer. The computer will detect where are the faces in the image, and then there is a classifier where you feed the face, and it will tell you whether this face has a mask or a no mask. So how did we build this classifier? With a huge data set with faces with masks and faces without masks. So you just need to think of an intelligent system, and then you have to build the model itself and integrate your model into this intelligent system. Okay, and another system, another thing that the computer with computer vision can do, it can detect like social distance violation. Like you see in this video, people they have green bounding box, and then when the people come near each other, it will become red, and it will tell you that there is violation. And then when they go away from each other again, it will remove this social distance violation. So how did we do this? It's computer vision. You detect persons, so the computer will be able to detect persons in an image because it was trained to do this. And then you like measure the distance between the 2 bounding boxes, and based on this distance, you can figure out whether these 2 persons are near each other or not. Another field of application, natural language processing. Just to mention, my main field in industry is computer vision. Natural language processing, it's very booming also, especially with Alexa, Google Home Mini, and all this stuff. It's a branch of AI and machine learning, because machine learning actually is part of AI that helps computer understand, interpret, manipulate human language. So we deal with this on a daily basis when you call your bank and an AI virtual assistant is responding, and it is actually the one that you are communicating with. So this is AI. This is machine learning. This is a model that was exposed to different conversation between clients and the human representative, and now it can actually guess what to say. And it's still, there is a path for this, for improvement. Even for me now, when I deal with this virtual assistant, they kind of make me nervous. They don't understand actually what I want, but I'm sure they are exposed to a very large data set, and eventually they will become better. Also sentence prediction. I think mainly in Gmail now, when you are writing email, even in LinkedIn, I guess it can predict what to say next. So this is a field also of natural language processing. Sentiment classification, to know whether this is like a positive review or negative review, like we mentioned for the tweets for the cinema. It's also worth mentioning that there is something called the Turing test, where people will try to build like an AI virtual person, and that you will communicate with this person, and you will not be able to judge whether this is a person or a computer. So people are trying to build a very normal, it looks normal, but it's actually based on AI human beings that you can deal with. Another field of application for machine learning is time series prediction, like detecting the price of Bitcoin price, like predicting the stock, predicting the flow of a river. All of this is time series. All these time series predictions. It's usually, I think it's used mainly in banks. Banks deal with numbers, so machine learning can help a lot in doing this time series prediction. So just to have a quick look of what we mentioned, we have supervised learning, which you can use to do regression and classification. So something like this, you have values for X and values for Y, and you would like to understand the relation between X and Y. This is supervised learning regression. You have classification, where you have like malignant yes or no based on the tumor size. So you can classify whether this is 0 or 1. This is binary classification. Another type of classification also is multi-class classification, where you might have like more than 2 classes. So it's not binary, actually more than 2 classes. And like we mentioned, there is clustering, where you will group some data points together. So how actually to do machine learning? Machine learning is kind of demanding for the tools you will use. More or less, it's coming easier. So people who used to do machine learning, like, because machine learning is old, deep learning is new. Now a lot of tools, a lot of like ecosystem is there, where people can ask a question on like Stack Overflow. You are a lot of open access courses where you can learn, but still there are some tools that you should be confident with. So usually people used to something called scikit-learn. It's free. You can use it using Python. So eventually anyone who would like to learn machine learning now, he should have like good Python programming capabilities. And he can use this scikit-learn to do the classification, to do the regression. And usually the code you will build will use something called NumPy, where you can, where your data will use NumPy to be formatted in a way that scikit-learn can use. So scikit-learn, you use like a free tool to build your model. You will program scikit-learn with Python, and you will use NumPy within your Python code to format the data in a way that scikit-learn can use. Another thing now happening since like 3 or 4 years, that machine learning kind of moved to something called deep learning. Deep learning is based on neural networks. So there are a lot of like frameworks that you can use to, they are open source. You can use them to build your model. So we have something called TensorFlow and Keras. This is offered by Google. And we have something called MXNet offered by Amazon. And we have something called PyTorch offered by Facebook. Apple has its own framework also, but it's not that popular. And Microsoft also has its own framework. But the main player in the field is TensorFlow. You see this curve for TensorFlow. PyTorch now is actually trying to increase again, trying to gain popularity. So it's like a competitor to TensorFlow. So if you check a job post, you will find them actually asking for maybe TensorFlow and Keras, or for PyTorch. MXNet also is trying, but most of the resources now online, if you'd like to learn, it's much easier, I think, to start with TensorFlow and Keras. So now where to run your code? The code to do the training, the code for your model is computationally demanding. So you can run your code on your machine, on your desktop. If you have like NVIDIA and graphics card, you can have build your own machine. This is kind of expensive, but then you can able to run your code. For sure, if you have like a simple model or something, you can run it without a GPU card like NVIDIA. But if you are going to do a real thing, you will need this NVIDIA graphics card. Another option is to run it on the cloud. So you can run it on the Amazon cloud, or you can run it also on the Colab. So Colab is the one that we will be using in the rest of the slides. What is Colab? Actually, you can actually Google it now while I'm talking. you can search for Google Colab. So Google Colab is a free service from Google, which enable you to run the code on the browser, and it comes with a lot of pre-installed software, so you don't worry about to install the software yourself, and give you also an ability to run your code to install other packages if needed. Yeah. It comes with some limitation. I think that you cannot run a code more than one day, and it has like another paid service that you can use if you want like more computation power. But even for the example that we are doing today, and for a lot of examples, you can just use a Google Colab. I think it just needs like a Google account, Gmail account, something like that, and then you are good to go, and you can play with a lot of examples with Google Colab. If you are dealing with computer vision, you will have to learn OpenCV for sure, which is Open Computer Vision. It's a Python library to deal with images and videos, and we also play with curves a lot to see how is our model doing. So we use something called Masterclass library. A lot of it's very easy to learn. A lot of resources, a lot of free YouTube playlists and a lot of tutorials online. You can just learn them. Okay, so let's take an example to actually see what to actually feel what can machine learning do. So if we are trying to solve a problem with regression, where if you remember, regression is something where you can predict a quantity. So in your code you will need to import some packages, some of the classes that you need. You will then provide the data. You should have the data. This is machine learning, so you need the data, and you have to do like some appropriate transformation for the data, and then you will create your model. So in our case, this will be a regression model, and then you will fit your model with the data. When you say fit the model, you can also say we can train the model with the data, so the computer now will have the chance to see the data, and then we will check the result to see did our model was well trained or not, and then use this model for prediction to deal with data that the computer didn't see before. Linear regression is a very typical way of doing regression, and within linear regression there is like simple linear regression where you have only one input and one output. So there is x as an input and there is y as an output, single variable. So what linear regression is trying to do, let's say that we have x and y and we have a lot of points. We need to fit these points somehow to a straight line. This straight line comes with the slope, and machine learning is it will learn how to get this straight line, what the equation for the straight line, using simple linear regression. Okay, so let's take an example. Let's say that we have this x value and this y value. So x is the input, y is the output. So if you input x, your output y. So 0 as an input will give you 3 as an output. 1 will give 5, 2 will give 7. So the relation here between x and y may be very simple one, but let's see how the computer can learn the relation between x and y. I'm going now to run the code on Google Colab. I'll be using sklearn. Okay, so I'm running here in Colab. You see, and let's see how can we very easy using sklearn and Colab build like a model that can learn about numbers. So this is a Python code running on Colab using sklearn. In the start, you need to import the packages and the classes you need, whatever libraries you will use. So here I'm using NumPy and I'm using sklearn. So I will run this cell. This is called cell, and Okay, it's run. So now I have this imported. I'm telling the computer that I will be using NumPy and I will be using sklearn. Now this is the data. This is the X and Y. I created them as a NumPy array. They are the same like we saw in the slide. So we just need to reshape the input to be in 2 dimensions. That's why I'm using dot reshape -1 and 1. And this is the Y. Actually, we know the relation here between X and Y. It's 3X plus 2. So if you multiply X with 3 and then add 2, you will be able to figure the Y. But the computer doesn't know 3X plus 2. The computer will learn how to understand 3X plus 2. Although this is a very simple example, but if we just change the data and the rest of the code is the same, the computer can actually be able to understand complex linear models. Then we create the model. So we said that we will be using linear regression. So I'm building the model, and that's it. The model is built. And now I will train the model. So I will feed my data to the model. I will feed the X and Y to my model. So I will model.fit. It's usually we use the word fit, but actually what we are doing here is training. So that's it. You build the model. If you have your data set, you build the model, you train the model. Now I would like to check the results. So this will tell me how confident is the model, what is the score of the model. So the score of the model is 1.0. It's from 0 to 1, so it's a very high score, because this is a very simple problem for machine learning. So it actually got all the answers correct, but this is not normal in industry. Definitely you'll have less confidence if you are dealing with actual problems. Now let's ask the computer to tell us give us more information about the values he found for the intercept and the slope. You remember we said that we know that the equation is 3x plus 2. So the computer figured that 3 is 3 because it's like 2.999 something, and the slope is 2. So it kind of understand that we are dealing with something 3x plus 2, and this is the predicted response from the model. It's 3579. It's the same as the Y values. Now we can apply the model for prediction. If we predict, it will give us all the Y. If a value like 12, and I'm feeding to the computer, so this is the value 12. I'm reshaping also to be 2 dimension, and then I'm using my model to predict, and I'm feeding X. I'm waiting for the computer to give me a Y value, and you'll find that the computer will give you 27. So the computer didn't see 12 before, but it figured out that if you feed 12, the output will be 27. Okay, I think we can take like a quick 5-minute break. What do you think?
I'm fine. Do you want us to start the questions now, or just take the 5 minutes break for people to kind of?
I think people might need, maybe this is a lot of information, I don't know. So maybe we'll give like only 5 minutes break and then we come back.
Okay. Everyone,
Okay.
if you need to grab your coffee or get some donuts or take some Coca-Cola from the fridge, this is the point where you get to do that. We will resume back at 12:54, which is in 5 minutes. Thank you.
Okay. Thank you.
Hi, everyone. I hope everyone is having a great session so far. We have gotten to our 5 minutes mark, and we would like to continue. So I want to kind of just talk a bit about why are you here? Why are you learning this? As a professional myself, one of the things that we have constantly talked about is that for the next 10 years, there's going to be increase in growth for STEM jobs. So it is being stated that 17% growth will happen in STEM jobs, while we will have 9.8% growth in non-STEM related jobs. Today, when we're looking at statistics, we see clearly that the economy of the world rests on STEM education, tech in general. We are also looking at the fourth industrial revolution kicking off, and we are seeing that for the next 50 years, these new digital skills are going to thrive greatly. Maybe you're listening to me today, you're located in Canada, or maybe you're located somewhere else. One thing that I know is that competitiveness, it's key. And to stay competitive at your workplace, digitization must be infused into what you do. Maybe this is the first time you're having access to machine learning or being taught on a topic such as this. I want you to think about this. Think about this when you leave this session. How is this relevant to what I do? Even if I don't want to become someone who is deep rooted in machine learning, can I pick some things from here? The second question I want you to ask is, how is machine learning related to what I do? How can I infuse machine learning into my work today? Is there any possibility for that? Because when you think like this, you are able to position yourself correctly. You are able to be one of those pioneers, one of those starters, one of those who starts conversation about machine learning at your workplace. We are hoping that during the time you spend with us today, you will not only listen, that you will be a contributor. You will engage us with your questions. If you are on the fence today, you're thinking, I need to change my career path. I want to transition to another area. You have that opportunity today to talk to a professor, to talk to someone who has done it all. He has been a professor. He has also worked in the industry to help provide you that guidance that you need to decide whether machine learning is the right thing for you. We hope that you stay with us till the end. And we hope that this session blesses you as much as it is blessing me right now. Professor, we're ready to get started and continue.
Yeah, sure. Okay, thank you. So
maybe before I let you continue, I want to mention that we have some materials that have been placed in the chat sessions for you. There is TensorFlow documentation, there is sklearn documentation. I also want to let you know that we have uploaded all the different Tech Master classes, even from previous series, to YouTube. That link is also available in the chat session for you today. We will also be adding other links there. One of them will be the ones for testimonials. Last week, we talked about the fact that STEMHub is trying to grow. What I mean by growth is we are trying to approach different organizations and we need credibility. Organizations are asking us whether we have real testimonials, whether we have real people who come to our program. We want you to help us tell them that you are benefiting from our program. So I'm going to share that link. And we want to hear from you, your testimonials, whatever you think we have done, whatever you think we're building. We want you to write it out. We will make sure that you are posted maybe with just your first name or your last name. We won't reveal your full identity, but we want testimonials because this, first of all, makes us better because we can see our impact. This also helps us be able to show the people we are approaching that real people are benefiting from our programs. Lastly, Dr. Walid has a YouTube channel. I'm going to be dropping his YouTube channel link. Please subscribe to his YouTube channel so that you can see some of the work he's doing. And he is on LinkedIn. I'm going to drop his LinkedIn handle. Please follow him if you have questions or anything. Please feel free to reach out. Thank you. You can continue.
Yeah, thanks a lot. Yeah, so back to linear regression, we took an example with a single variable. like this, where you have input X and the output is Y. You can also deal with something a little bit more complicated, where you have like the input is 4 values from X1, X2, X3, X4, and the output is Y. So 7, 4, and 8, and 6, if this is the input, the Y is 288. So again, this is linear regression. So we're trying to fit everything into a straight line based on the values of X1, X2, X3, and X4. Let's have a look and see how can we do this. I will share also the link on the chat. Okay, so it's kind of straightforward. You need again to import the packages you are needing, which is NumPy and sklearn. And by the way, it's great that there are shared resources for the sklearn, and the sklearn actually its own website offers a lot of tutorials and very straightforward to follow. So this is the X and this is the Y. This is the input. This is the output. So for example, if you input 2, 2, 9, and 4, you will output with 1, 3, 9. So again, we will create our model. We will train our model, and then we will check the results. So again, this is a very simple problem. So the confidence is 1, the accuracy is 1, and it gives me the values that this is the intercept and this is the slope. So this is like the information. You can build the equation. You can understand which equation the model found that can fit the X values to the Y. And you can do the prediction for the X values, and you can also do the prediction for values, different values that the model didn't see before. So here we are using model.predict, and we are feeding this 7486, and the computer, the model gave us 280. You are feeding 4631, and the computer offers 1603. Yeah, before I forgot, it's very important, like was mentioned, maybe you will not be that expert in machine learning coding, but you can have like a brilliant idea how to integrate machine learning based on your own experience. So a lot of startups are built like an idea. You have the idea, and then you can formulate it as a machine learning problem, and then you will have like your startup. So this is another example where we can use multivariable regression, also using just sklearn and NumPy. If we take something more practical, let's say that we would like to predict the home prices, and we will formulate the problem that the price of the home depend on the area, number of bedrooms, and the age, how old is the house. So we will go and collect some data for houses. We have to, if there is like missing data, and this is another something. This is something that you have to deal with. If you have wrong data, this is something that you have to deal with. So there is like so collecting the data itself and cleaning the data, making sure that the data is valid. There is like a job called data engineer for this, the one that he will collect the data, clean the data, format the data, and stuff like that. So let's say that we end up with this table for the values of area, bedroom, and age, and the price of the house. So by this and by using linear regression, we kind of say that, okay, the price is equal to certain value multiplied by area, and certain value multiplied by bedrooms, and certain value multiplied by age, plus a certain constant b. So this is because this is a linear regression, so everything should be like a straight line. So here we have like this dependent variable is the price of the house, and we have independent variables which we call features. So this model comes with 3 features: area, bedroom, and age. And it's left to the model to find out the values for this M1, M2, M3, and the D. So this is a very simple problem for machine learning, but it gives you also an idea. You can think of more complicated problems for sure. So let's run this code and see how can we build a model that can deal with multiple variables. Okay, and I will also paste now the link. Yeah, so here is the we import the packages, and now we have the data. So we have the data for the areas, bedroom, age, and price, and we have the X, we have them as X, and we have the output as Y, and we use NumPy to format them in a way that can be used with the sklearn model, and then we create the model. So the computer only deals with numbers. So these three values, like this is a house with the area 2600 and 3-bedroom, and it's 20 years old, and this is the value for the house, and so on. So you feed the data to the computer. Computer actually doesn't know the logical meaning of the numbers, but you are the programmer and you really understand them. And okay, and then you create the model, and then you fit the model. Okay. So you fit the model, and then you check the confidence of the model. So it's now like 95%, not 100%, and it gives you the variables to draw the line. And then you can use this to apply the model for prediction. So you can predict the data for the data that you see you already have. So this is the value 518,000, and this was actually 550,000. So there is an error for sure, but it's trying to predict the house. And then you can use this to predict prices for houses that was not part of your data set. So like this one, this is a house. This is the parameters for the house, the 3600 area, and 4 bedrooms and 1 year old the house. So this was the price. This house is a smaller house with only 1 bedroom and 40 years old house, and this is the price. So this is just an example, but you can formulate a lot of problems in the same way and use it, build a model, train the model, and use the model to predict. It's also worth mentioning that usually when you deal with a data set, you split the data set to a training data set and a testing data set. Common way to split the data will be like 80% training and 20% testing.
Dr. Walid, I'm wondering if you want to take some questions before we move on. Yes.
Yeah, sure. Yeah, sure.
Okay. We have 9 different questions in the box, and I'm going to start reading from the top. One person asked, can machine learning be applied to robotics? In a similar manner, somebody else also asked, can machine learning help improve virtual and augmented reality?
Okay, I don't know about machine learning and augmented reality, but mainly for machine learning and robotics, definitely yes. But this will be the field of reinforcement learning. That if someone understanding is interested in robotics, he will go for reinforcement learning, not supervised or supervised or unsupervised. For augmented reality, I'm not sure exactly, but I think there is some applications, but it's not like a very typical application for augmented reality.
Okay. Somebody else asked, can you suggest a tailored path to become a qualified machine learning expert?
Yes, definitely. So for me, I started with the website Coursera. They have very nice machine learning course by Andrew Neg. And so this is where you can start by taking this machine learning course on Coursera. You can audit the course also, but you will not end up with a certificate, but still you can learn. And so this is like the first step that you should take. you can still be with Coursera, and they have like a specialization, like deep learning specialization. We have like 4 courses. So I'm really fond of Coursera. That's why, because this is where was my main source of learning. So another website I think for courses would be like Udacity, Udemy. They have a lot of machine learning courses. You should have to check the rating for them. But I believe also you should try to take like a certificate in like university. I think York University has a diploma. University of Toronto, I think, has a diploma for machine learning, because you will be introduced to real problems and practical projects, and it's good to have it in your resume. But I would suggest learning Python on your own, taking this course on machine learning on Coursera, and then moving forward to take like a diploma or something. Like, also, when you start learning machine learning, you should be able to produce something. And so it's when we have like candidates applying to join us in the team, we look on which project they did. So usually developers will have their own GitHub repo. And so you should have your own GitHub. On if you think of any practical project, even a simple project, you should put it in your own GitHub repo, and you can create maybe like sample code that you can share later.
Okay, thank you. Before we leave today, is it possible for you to help us share some of those courses that you mentioned that beginners can take, or people who are trying to transition, so they can know which particular course they can target if they're interested in maybe the beginner one, or if they're interested in not just beginner one, but they want to kind of go step by step from beginner to next level to a point where they can be an expert?
Yeah, sure, definitely. I will share with you the information about like courses to learn Python, because Python, and then the course I mentioned for machine learning.
Okay.
Yeah, sure, definitely.
Thank you. Another question was based on using terabytes. How can you build a model using terabytes of data? How can you create an array around such huge data? That's one. Another person, do you want to answer that? Another person asks,
Yes.
can you please help me buttress on the use of scikit-learn? As we know, NumPy determines array.
Okay. So for the large data set, it's when we deal with large data set, we cannot use like a simple computer or even a simple server. So what we do, we use something called distributed computing, where we like the model is being trained on a cluster of servers, like 4 or 5 servers grouped together, so that they can deal with this huge size of data. And this is something actually related to also Hadoop and big data field. So it's mainly in the banking system we use this. So to deal with large size of data, you need like a storage for sure, and you need to learn about distributed computing. So it's usual if you have like a server with like 8 GPUs. Sometimes I do training on like 8 servers, each with 8 GPUs. So I'm dealing with like 64 GPUs. But you need to change your code a little bit to use multiple GPU and also multiple servers with this size of data. I don't know what is the second question. I couldn't get it. Can you hear me?
Yes, I can hear you.
Okay, so what was the second question?
Someone is, okay, you discussed the terabytes of data. So the other person is asking about scikit-learn. Ask if you can explain how to use scikit-learn, as we know NumPy determines array.
Yeah, you have I'm not sure I understand the question, but so if you use scikit-learn, you need to use numpy array for sure. And if you scikit-learn actually doesn't enable you to deal with large size of data. So if you are dealing with large size of data, scikit-learn will not be your target.
Okay. Somebody else is asking here, how long, or I don't know what would you suggest to train an already made model, or just modify the already trained model, or to train a new model? So what would you suggest? Train a new model or modify an existing trained model with new features?
Yeah, actually, this is a very good question. There is a field in machine learning called transfer learning, where you start with a pre-trained model. And then, so it's like a model that was trained with a large data set, like million of images. And then you use this model, this pre-trained model, and tune it to your smaller data set. So it's based on data availability. If you have enough data, you can train your model from scratch. If you are dealing with but if you don't have enough data, usually we do transfer learning. So you take a previous model, maybe trained on like ImageNet dataset or from Google, and then you use it to tune it on your own dataset.
Okay. Someone is asking, could you please recommend text in machine learning for beginners?
Like a textbook?
I think so.
Yeah, sure. There is a very nice book also for machine learning and machine learning with scikit-learn. It's like a standard book that everyone, I can't remember. Actually, I have it in the reference. Let me check. Yeah, this one, hands-on machine learning.
Okay, so
this one.
Yeah, thank you.
I think it's like the bestseller book. Yeah.
So please, if you're a beginner, you're trying to learn machine learning, please try to look at that and purchase it, and hopefully it will help get you started. We're going to work with Dr. Walid. Is going to provide us those links for courses that you can audit, and we will also send this by email. If you're not subscribed to our mailing list, please try to subscribe so that you'll be able to get this information sent to you so you can review them. And as we mentioned, we want to make sure that we keep in touch with you about the sessions that are upcoming. So please feel free to be part of the mailing list to be able to get this information. I think for now we can pause the questions there and move on, and maybe take another set of questions. So please drop your questions. I'm going to mark the ones that I already answered as answered, and please drop new questions so that after an hour or so, if we still have time, we'll be able to take follow-up questions. We've dropped a lot of links in the comment section, one for the testimonials. We will drop the one for mailing list. We've dropped a lot of links that Dr. Walid shared today. Please copy those links so that you can use them when you review this slide. So this again for your own use. Thank you.
So for the if you have your data set, it's the usual thing to split your data set, like 80% for training and maybe 20% for testing and evaluation of the model. So when you like publish the results, how good is the model? You don't evaluate the model based on the training data set that the model used to learn, but you test the model on the testing dataset, on the validation dataset, on the rest of 20%. So when training the model should not be exposed to the training dataset. The model should not use, the model should not be exposed to the testing dataset. The model should know nothing about the testing dataset. It can only learn from the training dataset. But when you do the evaluation, you do it on the testing dataset. This is very normal. So this this shows like it's kind of a cheating if you do the training on the testing dataset. You only do the testing on the testing dataset. So like this one, he got like very good results, but he actually what he did is that he trained on the testing dataset. This is a very critical point, that you will always separate your dataset into training and testing to make sure that your model generalize on the testing dataset, but you would never train on the testing dataset. So this raises also some two keywords in machine learning, the one called underfitting and overfitting. So this is a couple of problems that a practitioner in machine learning will face maybe on a daily basis, for the underfitting and the overfitting. So the underfitting is the model cannot capture the underlying trend on the training data. So the model cannot fit for the data, something like this. So they have the point, and your model is like a straight line, so it's not a curve. You forced your model to be a straight line, not a curve. So the model cannot understand the relation between the predictor variable and the output variable. If you have a better model, the model can have something like this. So it can fit your data. If you make your model more complex, you reach something wrong. You reach the overfitting, where the model will try to fit each and every point. So underfitting, your model cannot learn from the training data set. For optimal, this is the good one. For overfitting, your model did very good, extremely good on the training data set, but more good than needed, because it will fail to generalize, because it's kind of totally overfit for your training data set, so it will not be able to generalize. So this is the problem of overfitting. So we can actually spot it when we are doing training of our model. You will see that the accuracy of the training keeps on increasing, and this is like the training time. So we are improving, but maybe we are training too much. After this point, this is the training, the accuracy on the training data set, and this is the accuracy on the testing data set. So you do training on the training data set and test on the red one is the training, the blue one is the testing. But you train very much for very much time. So after this point, you find that the training is actually it's learning, it's improving, but your testing starts to accuracy is going down. So then definitely this is an overfitting. There are a lot of ways to overcome overfitting, like using a simpler model, using more data, and doing early stopping. For underfitting, you could use like a more complex model. I'm mentioning this because this is a very common issue that we deal with in machine learning for underfitting and for overfitting. Yeah, so the next problem that we will cover will be classification, which will be like a categorical data, like whether to classify whether this is the email is a spam or not, will the customer pay life insurance or not, which political party the person will vote for. All of these are classification problems, and the predicted value is categorical. For linear regression, something like home prices, weather, stock price, this is what we covered, and this is what we will cover in the next slide, classification problem. So classification problems is it can be like a binary classification where you have like two options only, like yes or no. Like if I'm classifying whether this is a cat or not, is it dog or not. So this will be like a binary classification. And sometimes you have multi-class classification where you will classify like what part would person vote for, and you have like three choices. So this is like a multi-class classification. So classification can be done um, in a different with different techniques for sure. But just to mention that this slide is from a very nice YouTube channel. You'll find the link here. It's called Code Basics. The channel is called Code Basics. So it's worth a visit also to join the playlist for the presenter. And this slide is from something called Simply Learn. I think Simply Learn is like institute that gives courses like diploma in machine learning, but they have also their previous courses online. So this is an example of classification about someone how much he will love the song. This is the intensity of the song, whether it's light or strong, and this is the tempo of the song, whether it's relaxed or fast. So I have two features here, and a red point means that this person will not like the song, and green point means this person will like the song. So it's clear for us that the person likes strong intensity and fast tempo. But this again is a very clear example. A lot of other problems use really machine learning. So now when we have a new song, like the A song, we can say, okay, this is a song that he will like. And for a B song, maybe how can we say that this is he will like or not? So one of the straightforward ways of doing the classification in this case is using something called k nearest neighbor, where we will get this song and we'll check the neighbors. All the neighbors of this song are songs that he likes. So in this case, we can predict that he will like this song. Same like if we have like the B song, we check the neighbors. We find that the neighbors also are good one, are the one that he likes. So we can expect that this person will like also the B song. How large is the neighborhood? Stuff like that. There are a lot of questions that you will have to deal with when you deal with like the k nearest neighbors. Some other problem, some other technique which is also straightforward, and if you're starting to learn machine learning, you'll definitely start with logistic regression. So this is classification, but using logistic regression. This is actually from Wikipedia, this slide, and Wikipedia also has a very nice introduction for logistic regression. So let's say that we need to find out the probability of passing an exam versus our study. So we know how many hours of study a student is doing, and we know whether he passed or failed. So this is a classification problem. You have here the hours of studying, and you have here the probability of passing the exam. When you have the data, you don't have the probability. You have whether he passed or not. So if he passed, it's 1. If he didn't pass, it's 0. So I have this point for 0, and you have this point for 1. But what logistic regression will output will not be 0 and 1. It will output a probability of passing the exam. This is a very clear example. Of course, if you study more hours, you have more probability to pass the exam. But this is like also typical thing that we can learn logistic regression from. So you'll end up having something like this. When you increase, so if you study for 2 hours, you have like 25% chance of passing the exam, and as long as you study more, you have more probability of passing the exam. Seems like if you study like here in 6 hours, you have like very 0.999 probability of passing the exam. So this is a logistic regression problem. Another one, if you predict if a customer will buy an insurance or not based on his age. So we have here the age of the person, and we have here the insurance, whether he bought an insurance or not based on the age. So for person, again, there is a very clear trend here that if the person is young, he will not buy an insurance. If the person is old, he will buy an insurance. So, but let's see how the computer can figure it out. So for a person 22 years old, he doesn't have an insurance. For a person 52, he didn't. This person didn't get an insurance. 56 got the insurance. 55 didn't get. All these persons got the insurance, and so on. So it's something like this. This is the age, and this is the have insurance or not. So for these ages, the person didn't get an insurance. For this, the person got an insurance, and maybe you will find some points like this where the person is old but he didn't get an insurance also. So we cannot sit here like a line. We cannot use linear regression. That's why you are using logistic regression. No line can pass with this point. So we need something else. So what we use in logistic regression is a very simple part of math. We use something called sigmoid function, because we will not output a value. We will output a probability. We will output a probability between 0 and 1. So we will use something called sigmoid function. Sigmoid function is 1 over 1 plus e minus x. Nothing very complicated. It's the output of a sigmoid function is always a value between 0 and 1. It's always a value between 0 and 1 because this is a probability. So, and if you feed this sigmoid function with 0, the output will be 0.5. So we will use the sigmoid function in the logistic regression because we need the output to be a value between 0 and 1. It's a probability. And nothing, we don't need anything to be more than 1. We don't want anything to be less than 0. That's why this is a very convenient function that we can use. So we will fit our data in logistic regression into a sigmoid function. So this is the probability. It's equal to 0, and it seems like with the age is increasing, there is increasing probability that this person will buy the insurance, and that's why sigmoid function is always used with binary classification. So we are kind of using the linear regression, moving it into logistic regression by doing something like this. If you are doing linear regression, your equation is y equal mx plus b. But if you are doing logistic regression, y is equal to 1 plus e power minus x plus b. So it's the same like this one, but instead of having here x, we put mx plus b. If you find this is like complicated or something, it's very straightforward. If you spend time with it, you will find a lot of like tutorials how to do logistic regression and how this sigmoid function is used. Let's use the Colab again and do this logistic regression. So again, we do the import, and then we prepare our data set. So this is the age. So a person 22 didn't buy insurance. A person 60 bought an insurance. Person 25 didn't buy insurance, and so on. So this is the age, and this is the bought insurance. Usually we define the input as x and the output is y. So this is x age and y is bought insurance, and we prepare them using NumPy in a way that can be fed to the model, scalar model, and these are the points. Okay, and now we will do the split. You remember we mentioned that you train on the training data set and you evaluate on the testing data set. So this is the first time to do this training and testing, but this is a very common thing to do. So usually we use sklearn also to do this train test split. It's a very simple line that it's a function called train test split. I'm sending the x, the y, and I'm here mentioning that 70% of the data should go for training, and 30% should go in testing, and it will return X train, X test, Y train, Y test. So X train,
Professor, there's a question about if we can, someone is asking that he didn't get why we couldn't use linear regression, that if we can take that part again.
yeah, sure.
Thank you.
So if you deal with linear regression, there is no line that can fit on this data. You will need a straight line will be something like this. So no linear line will be used. So we cannot use a linear line to fit on a data which is 0 and 1. So you will need like a sigmoid function. So what we are doing here is that we are converting this line into this sigmoid function, so that I will not fit the data into a line. I'm kind of fitting the data into a sigmoid function. But the sigmoid function itself will still depend on this straight line, as I'm feeding this straight line into the sigmoid function. So here we splitted the data, and then we will create our logistic regression because we are doing classification. So when we were doing regression, we used linear regression model. Now we are using logistic regression, and then we train. Maybe I will add. Okay, so now we build the model, and then we fit the model to the data. So now we can do the prediction. So it will tell me that this is the Y predicted and this is the X test. So this person will not buy insurance, this person will not buy insurance, this person will buy an insurance, and this person will buy insurance. So 21 years old didn't buy, 46 didn't buy, 47 bought, 67 bought. I'm using here X test to predict. So I'm using data that was not seen before by the model, but still the model kind of has sense, understands how to predict whether the person will buy an insurance or not. So the output actually also, this is maybe refer to the question about the sigmoid function. The output is actually a probability. So for a person 21 years old, the probability not to buy is 0.99. For a person 46, not to buy is 0.56. For a person 47, now the probability not to buy is 4.3 and the probability to buy is 5.6. For a person 67, the probability not to buy is very low and the probability to buy is higher. So the output of the sigmoid function will always be probability. Here and so sklearn will give you like two values. If you sum both values, it's always 1. So this is like the probability of 0, and this is the probability of 1. This is the probability of the person not buying the insurance, and this is the probability that the person will buy the insurance. Just to check how the model is doing, and let's take an example. If the person is 12 years old, he will not buy the insurance. So age equal 12, and model.predict 12, buy insurance equal to 0. If the person is 30, he will not buy the insurance. Person is 50. Now there is like 87% chance that he will buy the insurance. person is 80, there is like a 99% that he will buy that. Maybe such a this can help in marketing maybe because like an insurance company, not only for the age, you can like take the number of children, type of the car, the job, and use this to build your model for the whether the person will buy an insurance or not. Last thing we'll cover will be like a very quick idea about deep learning. So deep learning is like the trend now. So people move from machine learning somehow to deep learning. So if you think of AI as a large field, it has machine learning within it, and within machine learning now we have deep learning. And like I mentioned in an early slide, deep learning comes with packages like TensorFlow, PyTorch, MXNet. But I still recommend to learn the basics of machine learning like linear regression, logistic regression, support vector machine, anomaly detection before moving to deep learning. So you cannot jump directly, I think, to deep learning. It's better to take machine learning. So now people are leaving all this thing. You see like here is farewell to logistic regression, farewell to support vector machine, KNN, and everything. People are moving to deep learning. So even the logistic regression and the linear regression that I mentioned today, they are still used for sure, but not as common as deep learning. Even now, when you do the linear regression and logistic regression, you do it in a deep learning way. You do it with neural networks, which is like the field of deep learning. Even the scikit-learn that it's like it has been there and like typical things that people use. Usually now, like scikit-learn is used only to split the data. If you remember the line that we used to split the data between train and test. So now it's as if scikit-learn, people are just leaving it and just using it only to do this train test. So deep learning can be used for different tasks. If you are dealing with computer vision, you will not use scikit-learn. You will use deep learning. So what can the computer vision do? Computer vision can do image classification, which will detect whether I think the emotion of the person here based on the image. It can do something like object detection, where it will detect person. It can do face detection, detect the face and verify whether this is a person or not. It can do something like pose estimation, where it will detect the key points on the person. It can do something like neural style transfer, like taking an image as a photo and taking it a painting and then redraw these images as if the painter painted this image. This is a simple example also for the emotion detection by deep learning. So we detect the face here, and then we detect the emotion, whether he's sad, neutral, and then we show the percentage for the emotion probability. So what we are doing here, it's so you feed the video, you extract the images from the frame, you detect the face, and then you feed the face to a model, and this model was trained by a data set which has different facial expressions, and then you classify the emotion on the face. For something like face detection, for sure you will not be the first one to build a model for face detection, because actually we build the model for you are using a model to build face detection. But there are a lot of like freeware models for face detection. That this I used one, I didn't train one. I used a model for face detection, but what I did train in this example really is this emotion detection based on this data set. So just a quick look, what is deep learning? So deep learning depends on neural network. It has a computation unit called neuron. So neuron have the input like x1 to xn, and then it's multiplied by weight, And so it do something like sigma xw for all these inputs, and then you pass it to an activation function, and this is the output. So this is like a computation unit. You feed the input, you get the output. So this can be used to build linear regression and logistic regression also. If you think of this activation function as sigmoid, you are having like a neuron that can do logistic regression. If you remove the activation function, you are actually doing linear regression. So when you do training, you wait for the you ask your model to learn the weight, the W1, W2, W3, and so the model will learn what should be the values of the weight. So this is like a computing unit, neuron. So now we have a neural network where we have a lot of these neurons stacked together as layers. So this is layer 1, layer 2, layer 3, and then you have the output. Each one of these is a neuron. So what is deep learning? Deep learning is a deep neural network. So we have a lot of layers, and this is neural network. This is a deep neural network. This is where the word deep learning comes from. And you can imagine now that we can go deep like 154 layers, 200 layers, 300 layers. But for sure, there is a price when you go with a large number of layers. Your network will be slow to train and a little bit slow also to predict. So training neural network, it's the same concept like training an scikit-learn, but it takes more time. This time it takes more time. So it's like something like this that even for me, I can train a model for like 2 or 3 days, even using like like 8 GPUs. I still like start the model setting and leave it working, and then come and check the results maybe after 2 or 3 days to see how things are building up. So this is an example how to do like linear regression, but using deep learning. So it's a little bit complicated than scikit-learn for sure, but I'm using Keras and TensorFlow. Keras and TensorFlow trying to have like a human code, which is like readable code. So this is the model I'm building. I'm building a sequential model, and it will have something called dense layer with only one unit. Dense layer with only one unit. So if you run this, you have this model, and this is the same example that we did with linear regression. I'm just doing it now with the Keras and TensorFlow. So this is the data. Here you need to tell explicitly to the deep learning what will be the optimizer, which way the model should try to figure out the values for the weight. So here I'm telling use the SGD optimizer. Use the SGD optimizer to try to figure out the values for the weight. And the performance measure here will be the mean square error. So you are telling the model use SGD to find the values of the weights, and your performance index will be the mean square error. Then we do the fitting. So even in deep learning they use the same word fit. So I'm fitting the X and Y here, and I'm training for 500 epochs. It's like 500 iterations. So this will take, okay, I can compile the model. This will take some time. You see, it's learning, and you can see that the loss is decreasing from one epoch to another. So we started with a high loss, and then each epoch, your model is able to find better ways for the output. So I'm running on GPU because Google Colab gives me a GPU, but still you can see that you kind of have to wait till the model finishes. The process is decreasing. It takes 2 milliseconds per step. hopefully finished. So it's still training, still training. Yeah, now it's finished by 500 epochs. You can do the prediction, and it will give you the value. So to understand what happened here is that each epoch, it was learning better weights from, so the loss will be like decreasing till we end up with a very low loss at the end. I will touch on this very quickly because from within deep learning we have something called deep learning depends on neural network. We have something called convolutional neural network. It's a neural network with different type of layers that you can use to classify an image or do different applications for computer vision. So we saw that in the last example we used something called dense layer. Now you can use something, so with convolutional neural networks you can use different types of layers, like convolution layer, pooling layer, fully connected layers. So you like kind of stack these types of layers together. It's well suited for computer vision application, and then you can classify the image. So in this one, in this image, you classify that there is 0.1 probability of a dog, 0.4 a cat, 0.94 deer, and 0.19. So you get like an output. You can have like all the outputs should it can be a sum of one, or you can have like leave it like this. But it's a very well suited convolutional neural network for the computer vision application. So a very straight typical example that people learn how to do classification is using the MNIST dataset. It's like hello world in classification. So we have the digits of 0 till the digits of 9. So you build a neural network that can classify the digits. So even if it's like a handwritten digit. So people use this to do to make sure that you understand how to use the convolutional neural network. So convolutional neural network is still a neural network, still related to deep learning, but it's more suited for the computer vision application. So you do the importing. I need to. Okay, I don't think Google Colab will enable me to run this one because I have a lot of sessions running. So anyway, this is how do you import. Here we load the data set, and then we like draw the digits, and then this is our model. This is our model. It has like a convolutional layer followed by max pooling layer, by convolution layer, by max pooling layer. And then I'm using this Adam optimizer. So I'm telling it, try to figure the weight using Adam way. And this is how the loss will be calculated. And then you will do the fitting. And here you see the training data and the validation data. And then you calculate the accuracy on the training data set, the accuracy on the validation data set. I'm not sure I'll be able to. Okay, no, it's not on it. Okay, so I think that's it. This is the last slide in the presentation. I'll be available. Let me answer some of your questions for sure. I have. You can reach me on LinkedIn. You can reach me. You can just email me, and I will definitely reply.
Okay. Thank you so much, Professor. Thank you for taking us through the session today. We still have some questions here. If it's okay, we'll ask.
Yeah,
and And before I proceed to ask questions, I want to announce to everyone that our next session is on project management. So we know that this week and the previous 2 weeks have been very technical. We went from data analytics in Excel to building up using machine learning. As you can see, there is a little bit of overlap between what you learned last week on regression and stuff like that and what Professor Walid taught this week. Next week, we'll be focusing on really doing project management, not just the theories, but we will be using ClickUp for the practical side. So you will learn about the different theories, different things that you need to know on the theory side, but you will also be able to learn how do you build tasks, how do you manage tasks, how do you manage time, your time, how do you do integrations, how do you complete customization, and how do you have your team collaborate together. So the target audience for next week is people like you, professionals who work in teams, who need to understand how to manage their projects. Maybe you are in school right now, you're a PhD student, you are a professional, you are building a business on your own. Next week, we'll provide that opportunity for you to really get an understanding of data management or project management beyond just the theories, but really executing it in ClickUp. All right, I'm going to go into questions. If you're still on the call, you have questions, please drop the questions in the question box and we'll go back to start from at the top. Someone is asking, how do you know machine learning is the right solution for a particular project or issue?
Yeah. So as long as you have the data, this means that there is a potential for machine learning to learn. But this is actually a very good question also because it seems now that it might be like an overkill. Like maybe the problem is not suited for machine learning and people just use machine learning. Like a lot of startups move to the machine learning. It's like a false machine learning. So I think if you can formulate your problem that you have the input data, the output data, and that a model will help you to get the output, and you have enough data to train and enough data to validate, this means that this is a machine learning problem.
Okay, thank you. Another person is asking here, what level of Python knowledge is required to venture into machine learning?
I wouldn't say that you need to be an expert in Python. A beginner level in Python or an intermediate level in Python will help, but you will learn by doing. So just learn the basics of Python as a beginner. Python is a very intuitive language, very readable language. So don't get overwhelmed by learning Python. Get the basics of Python and then move to machine learning. And if you find some code in machine learning that you don't understand, because when you learn, so when you deal with machine learning with Python, you will need to deal with JSON file, with CSV files and stuff like that. What I did is that, okay, this is now I need to deal with JSON. Okay, let me read now the part of Python that deals with JSON, and so on. So learn by doing for sure.
Okay. Another question is from a student who is a final year chemical engineering student. And this person is thinking of a career in machine learning in the future. And this person during the lockdown has been taking some Python programming languages. So he or she is looking for whether you have suggestions of how to connect the dot between chemical engineering career and really machine learning.
Yeah, I have one of my friends actually published some papers, but it was regarding to the air pollution. So I think this is related to chemicals. Yeah, this is the only example that I have in mind. I do also for a chemical factory optimization. Maybe you can check how to optimize the operation of the chemical factory. Maybe even for a simple equation, like a chemical equation, how can you decrease the losses in the equation? I don't know also if chemical maybe is related to the AI medical, because AI medical now is very booming, especially with COVID-19. There is a specialization on Coursera for AI medical. It's for the medical application, so maybe someone with a chemical background will be more suitable to learn about AI medical. They do diagnosis and stuff like that. Even for drugs creation, something like that. So the AI medical also might be suitable.
Okay, thank you. There's two questions pretty much focusing on what we just learned. One of them is there a type distribution of data between testing and training?
Yeah, people split it like 80-20, 70-30. And sometimes when your data is very low, you can split it like 90-10 or 95-5%. But you have to make sure that you have left some of the data with a good representation that it represents the different problems and put it aside for testing.
Okay, thank you. Is sigmoid function to avoid underfitting?
No, not to avoid underfitting in a way. It's sigmoid function because you are dealing with a classification problem and you are opting the probability. So it's not you cannot say that you are using sigmoid function to avoid underfitting. If you have underfitting, typically you just increase the complexity of the model, like adding more features to the model, removing irrelevant features. So if you have underfitting, you go to a more complex model, not like a linear model, maybe a polynomial model. You create more features. This is for underfitting. And the contrary, if you have overfitting, you go to simplify the model.
Okay, thank you. Someone is asking if they will be able to get access to the slides and links to access the labs.
Yeah, definitely. I will share the slides with you. It's now on Google Share, so it's a link. And within the slides, you will find links to each Google Colab.
So if you haven't signed up to the mailing list, please make sure to sign up so that you will be receiving the link to the slides from us. Thank you. Someone is asking for the prediction model, can you use Y instead of X? That is, can you predict the age bracket from maybe 20 years to 87 years and then clarify them into buy and not to buy, 0 and 1?
Yes, it's actually, it can be done. So the input can be, but you will have to categorize the input. Let's say that we will deal with people like 20 to 30, 30 to 40, 40 to 50, 50 to 60. So you need to prepare your data like 0, 1, 2, 3, 4, something like that. So if the input is 0, this means that I'm from 20 to 30. If the input is 1, I'm from 20 to 30. So you have to do some encoding for the data, and the input here will be categories. This is actually a very good question, but you have to encode the categories as values and feed them as an input. Even for applications that do the other side, like prediction of the age, a lot of them wouldn't predict the age, but we will give you, this is as a Y, will give you the range of the age.
Okay. Someone asked, can I do machine learning with just knowledge of SPSS and Stata without background in coding? No,
you can't.
No, unfortunately. I think it's a good background to have, especially because it helps you with understanding your data, regression, and all that. But I also think you need coding. Yeah, and we shouldn't be running from coding anymore, especially Python, because this is going to be the basics for a lot of things that will be built, right? As we started in the past, there were COBOL and Fortran language was the basics for a lot of things that got built. So Python is going to be the basics for things that will be used 50 years from now, 30 years from now.
Yeah.
So the earlier we get to it, the better.
Totally agree. I think reading, writing, and coding.
Yeah. Someone is asking, in a nutshell, what will it take one to carry out a simple face recognition project?
Okay, so for face recognition project, you should start with having the data set, which will have the different faces. So what we do is that we, let's say that we are doing a data set for face recognition for celebrities. So we are doing like Brad Pitt, Jennifer Aniston, and stuff like that. So we have like a folder of images for Brad Pitt, a folder for images for Jennifer Aniston, and so we should have the data ready for sure. And then what we do with deep learning is that we will take from each image, we have a neural network that will take the image and output like a feature vector, like 64 values for each face, 64 values for each face. But that's 128 values for each face. So I have like a feature vector that represents each face. And now when a new face comes, I will encode this face also as a feature vector, and then I will compare it to the feature vectors of like Brad Pitt and check the similarity. And based on the similarity, like the distance between the feature vector, I can say that this person I can recognize the face.
Okay, thank you. R versus Python, which is a better language to learn future-wise?
It's Python for sure. It's better after Python to know C and C++. But
Python.
You start with Python. Yeah, you start with Python. There will be a higher demand in industry if also you know C and C++.
Great. Please, which sites can I get real life projects and practical with machine learning skills? I need projects I can lay my hands on to be able to practice based on this present knowledge that I have acquired.
Okay, there is a website called Kaggle. Kaggle. It
Can you spell it?
Kaggle. Kaggle.
Kaggne.
Yeah, Kaggle data. This is a very well-known website. It has a lot of free data sets that you can download. And there's a lot of actually competition within it that you can use, and you can build a model and test it and then publish your results. And you can get like ranked in this Kaggle data set. So the Kaggle website is, you can start with downloading data sets and build your own like portfolio, because like I said, you need to have like your own GitHub repo with projects. So you can start with this Kaggle dataset because it's also a benchmark dataset. So you can say that I trained my model on this dataset and this dataset came from Kaggle.
Okay. All right. I think that's all the questions we have, Dr. Walid. Thank you so much for leading us in this powerful session, 2-hour session today.
The pleasure is all me.
Yes. Yeah. Everyone, like I explained previously, we have uploaded all the sessions, previous sessions from series 1 and series 2 to our YouTube channel. Please feel free to visit the YouTube channel to rewatch some of the sessions. We also have here the mailing list. If you're interested in joining the mailing list, we've shared with you Dr. Walid's LinkedIn profile, YouTube channel, and Medium channel for you to be able to read more. Please feel free to reach out to him if you have concrete questions about career paths in data in machine learning. One thing that I know is that the future of work is going to rest on the shoulder of tech. And as people, for us to really be able to be at that point where we're economically strong wherever we are around the world, it is important to not be afraid of tech, to really think about how do I delve into tech. Today, we have learned that the future of a lot of technical work will rest on the shoulder of Python. Please take your time to look on Coursera, Udemy, anywhere where you can get an understanding of Python from, even if it's just 3 hours every week. We want to challenge you to invest some time in understanding this programming language. We know that not everybody wants to become a tech professional, but we also understand that adding this to your career will make you more competitive. From experience, if you're thinking of maybe migrating to Canada, you're a new immigrant in Canada, you went to school in Canada, you're thinking about being competitive, I feel like learning Python and thinking about how this affects your work is a plus. So thank you all for staying with us, for spending 2 hours with us today. Please follow us on social media to have an understanding of what is going to happen next week. We're really excited that we're going to take you away a bit from tech and take you into the world of project management next week. Until next week, thank you from your host, Dr. Adi Olubamiji, and Uchi stepped out, Uchi from AfricaHacks. We thank you for your time today. Enjoy the rest of your weekend. Please connect with us on social media if you have questions, and we'll talk again next week. Thank you. Bye.